If you've seen the video with an example of the surfaces actually rendering in my new 3D engine with point by point, so it's just showing different boxes, this view will probably be quite obvious to you. I've got them in a slightly mirror image to what we actually see in the video. The idea of hidden surface removal is if any surface, such as this one here, is within another surface, that we actually remove it from the calculations before we try and draw it to screen. There is a quite complex way we can do this. This is a top-down view as if we've got a virtual camera. That's what this triangle is here, and this is its view cone, if you like, and this is its focal point. What we can do is we can do an analysis over the angle that each of these lines makes for each of these different walls. And we can say that if the angle that this wall here makes is within the angles that this wall makes, don't need to show that because it's behind the other wall. However, there's actually a much quicker way of doing it, although it's not as accurate, doesn't work nearly as well, but will work well enough for what we're going to do for this 3D engine. So as you remember, this is the viewpoint that we see. And what I do is literally draw a rectangle from point to point and see if the wall actually is within this wall as well. So if it is between, if any of these 4 points on the internal wall are behind this rectangle here, then it's not shown. So you get a scene that looks like this, where this rectangle is shown because only 1 point is behind the blue wall, which is closer to the camera. But if all 4 points are behind a single surface, then it's not shown. Now I've deliberately made sure that the algorithm only works that if the surface is behind one single surface. So if we have a situation like this, so imagine this wall here is closer to the camera than these 3 walls, which is like a back wall. Within this surface that you see here, the following rectangle will be created. And as you can see, no wall behind the scenes actually is behind all 4 points behind this side wall. Therefore, none of the walls are actually removed, even though there is some data that could be hidden. Similarly with this set of walls, even if there's another wall after this one coming out from here, this wall will still be drawn because 2 points are occluded by the wall in front, and these 2 points are occluded by this wall. Because I'm still doing a back to forward drawing algorithm, this won't actually matter. It won't cause a problem with how it looks on the screen. It just means it's processing unnecessary information. But that's a price I'm willing to pay for the speed that this actually produces for removing hidden surfaces. So on this example, only this middle square would have actually been removed. To do this, I'm having to convert the list from a tree structure into a double linked list to know which surfaces are closest to what, and I use a recursive algorithm to make sure I know what to remove and what I don't, and where I am in my list, and I start from the furthest wall going towards the closest.